welcome back. We ran out of time in the last one, so we're still on set 2, but we're looking at gradients using the rise over run method, and we were up to looking at a negative slope. So you can see in this second example that as you go from left to right, it slopes downwards, okay? So you need to be able to recognise a negative slope because this has a different meaning for your rise and your run, okay? If we draw our triangle, you can see that we've got our run across here and our rise here, but it's a negative rise. We're going down as we move across. So the value for our rise is a negative, okay? And our run will always be positive. So this is a really good summary of what you need to do for the first formula. So always write out your formulas and then substitute what you know. So our rise is -4 because it's a negative rise, and our run is 5. So your answer could be -4/5 and leave it as it is, or you could turn that into a decimal by dividing the top line by the bottom line in your fraction. And so every time we go one run across, we go down 0.8. 1 unit across, down 0.8. That's what it means. So it doesn't matter with this formula if you're crossing in the positive side of the x-axis or down here somewhere or up here. You just need to individually count the units and remember these basic rules. So I recognise this, so the first thing you need to do is recognise, is it negative or is it positive? And as we go across from left to right, it slopes down, so we're going to have a negative rise. So what will that negative rise be? 2, 4, 6, 8, 10. And our run is always positive, so that's worth 5. So 10 divided by 5 is 2. Negative divided by positive makes a negative. So our gradient is -2. So that means as we go across 1 unit, down 1. Across 1, down 2 units. Across 1, down 2 units. So that's the very first way of working out the gradient. And this is very useful when you've got your graph and you can quite easily just count up the units as they are. Let's use the formula method, which is for gradient y2 minus y1 divided by x2 minus x1. So the first thing that you need to do with this sort of problem is you need to label each set of coordinate points x1, y1 and x2, y2. It doesn't matter which ones you start with, you will come up with the same, which pair you start off with, you'll come up with the same answer. You just need to be consistent, x1, y1, x2, y2. And so when I see y2 in the formula, I'm going to substitute in 4 minus y1, which is 3, divided by x2, which is 5, minus x1, which is -2. So it's really important that you use your symbols, take your symbols with you. So let's go. 4 minus 3 divided by 5 minus 2. So a minus makes a positive. So 4 minus 3 equals 1 and 5 plus 2 is 7. So our value for our gradient is 1/7. Now I haven't got the room and I'm writing across the page, but I would like you to line up all your equal sides underneath each other and down the page, please. I'll show you what I mean in the next example. So looking at our next example, we've got -5, 6, so x1, y1, and this one we'll label x2, y2. Let's change my pen. Every time you use a formula, I suggest you write it down and you will then start to remember it rather than rely on the formula sheet that I gave you. So negative 6 minus 6 divided by 1 minus 5. So a minus 6 makes a bigger minus, and 1 negative makes a plus. 1 plus 5 makes 6. And so your answer for A equals -2. Pause the video and have a go at page 38, questions 3 to 6. The next thing that we're going to look at is the equation of a straight line. So we've already touched on what some of these things mean. So this is our general equation, y equals ax plus b. The number which is next to the x, or you can refer to this as multiplied to the x, is our gradient. That's what we've just been working out. The number that is added to, or in some cases might be subtracted from the x, is our y-intercept, where it crosses our y-axis. So we can start to form a picture from some of our equations of lines in these 4 examples, and then I'm going to sketch them over here. So y equals 3x minus 2 is our first example. So our gradient is 3, and our y-intercept is -2. So we could plot that, or I could at least sketch it. So I'll just get my ruler up. So I know that it's got quite a steep gradient. Every time I go across 1 unit, I'm going to go up 3. It also tells me by the information that it goes through -2. So it might look something like that. Okay. The second one, y equals -x plus 4. So -1 is our gradient, and +4 is where it's going to go through the y-intercept. So it's a negative gradient this time, so it might look something like this. Okay. So you'll get to the point where you can draw a graph like this. We're not at that stage yet, but just so that this is the sort of thing that you'll be working towards. Y equals 5x. Now don't be put off that it doesn't have a plus or a minus here. Okay, that will tell you that it's +0. Okay, it means that in fact that it's going through the y-intercept here at the origin. Okay, and it's quite a steep gradient, so it will be something like through here. Likewise with this example, there's no x term. So that must mean that there is no gradient. So that means you'll get a flat line. So let me draw that one in. So it will have no gradient. It's going to go through at about 6, so it would be somewhere up there like that. So the first thing that you're going to do is start to identify these things. Okay, the gradient is always the number that is next to or multiplied to the x. So all these ones, you can straight away work them out. It does not include the x, it's just the single number. It shows you how steep the line is and which way it's sloping. The number that is added or subtracted to the x is always your y-intercept, where it crosses the y-axis. And you know, if there's nothing there, then it must be 0. It must be going through the origin. So let's write those out more formally. A equals 5, and the symbol for our y-intercept is a b. You may be more familiar with that being a c, but we use b at this level, and so that's at -2. So with these questions, you could go through them quite quickly, and a common error is just to mix them up. So make sure you remember which one is attached to which. Okay, so that's how you'd write that answer out. The other way that you need to be able to do is to work backwards. You're given your A and B, your y-intercept and your gradient, and you just have to put it back into the general equation. So your general equation looks like that. And so wherever we see A, we're going to put a 3, and wherever we see B, we're going to put a 2. So it would look like this. Again, when we see a gradient of -2, we'll put it in, and our y-intercept is 0. So that we don't write +0, we might in the first instance, and then you might tidy that up and simplify it to y equals -2x. The last example, our gradient is 1 and our y-intercept is +3. Again, convention is we don't write the 1, and there's your example there of the last one. Have a go at page 39, questions 7 and 8. You need to do all of those. And pause the video before you move on to this next screen. So with this third type of example, you have to not only work out the gradient, but you also have to work out the y-intercept. And hopefully you can see the y-intercept straight away. In the first example, it's going through +5, and in the second example, it's going through +3. So that's something you can straight away work out by just looking at the graph. But you need to work out the gradient, and so you'll need to do a calculation. Okay, so you've got your rise and your run. So the first thing I'm going to do with my gradient is work out, is it a positive gradient? And yes, it is, because as I move from left to right, it's sloping upwards. So that means it's a positive rise. And our run is always going to be positive. So there are 5 units there, and there are 5 units there. So our gradient is 1. We know our y-intercept is +5, so we can now formulate our equation by substituting it into the general equation, y equals ax plus b. So a equals 1 times x plus 5. And that's the equation for this line. The second example is an example of a negative gradient, because as you move from left to right, it slopes down. And so you can see that it goes through at +3, the y-intercept, and we just need to work out our rise over the run. So as we slope from left to right, it's a negative rise, and our run is worth 1 unit. So a rise of -3 divided by a run of 1 gives us a gradient of -3. So always solve these out or simplify them as much as you can. And so now we've got all the information to put it in the general equation. So y equals -3x plus 3. And that's our answer. So I'd like you to have a go at question 9 particularly. And if you can do that quite well, have a go at question 10 and try and match up the equations. There are no numbers, the equations with the graphs. But you definitely need to do question 9. And the last thing that our classes have been doing is transposition. So this is earlier on in your book in set 1. So just turn to that page. I think it's 9 or 11. Now on this page, it's quite a complicated transposition, so we're not really going to talk too much about this one. But what transposition means is we're going to rearrange an equation so that an alternative variable becomes the subject. So that means instead of p being the subject, we're going to make something like x and rearrange it, move x over to the left-hand side, all the other numbers and letters onto the right-hand side, and then we've got as x as the subject. So this is quite a complicated example, so we're not actually going to go through that one. We're